So in this short tutorial, we are going to go through a few more Mole Island style problems from unit packet pages 12, 13, and 15. So first let's turn to page 12 in the unit packet and let's go through Moles 1, problem 1b here. So it says that we were given 62.8 grams of barium chloride. So it's important to know that barium chloride is BaCl2 because barium's a +2 and chlorine's a -1. So I'm going to write down what I'm given on the left-hand side of my page, 62.8 grams BaCl2, and then it asked us to calculate how many moles are present. So I'm looking for moles of these substances, so I'm going to go ahead and write down what I'm looking for on the right. Moles BaCl2. Now, if we're wondering how many steps this is going to be, let's go ahead and go all the way back to Mole Island and see we're starting from grams, we're going to moles. We're going to use this information, the x grams per 1 mole, which is from the periodic table. So when we look at the periodic table for barium chloride, we're going to have to add up 1 barium, which is 137.33 grams per mole, and 2 chlorines, which are 35.45 grams per mole. That ends up being 208.23 grams of barium chloride per 1 mole of barium chloride. Now I put grams on the bottom so that the grams unit cancels, and now I'm left with moles of barium chloride on top. Now to solve this problem on my calculator, I would take 62.8 and divide it by 208.23. Now my calculator says 0.301589588. Always look at the thing we're starting with. I have 3 sig figs right here, so let's go with 0.302 moles. Let's go with 3 in our answer. And there's the answer. 0.302 moles of barium chloride are 62.8 grams of barium chloride. Okay, let's go down and do another problem, but kind of the reverse of this. This time we're going to start with moles, and we're going to calculate the mass. Now again, we need to be able to look at a name and identify the formula. Potassium, K plus 1, nitrate, NO3 minus 1, so these are already balanced. Potassium nitrate is KNO3. Write down what you know. I have 5.03 moles of KNO3 on the left. I am looking for grams of KNO3. Put that on the right. It should always be the first and second thing we do. Go back to Mole Island if you need to. And again, we're going from moles to mass. This is going to be one step again. All we need to use is the periodic table molar mass, x grams per mole. Now looking at KNO3, we have 1 potassium atom, 39.1. We have 1 nitrogen atom, 14.01. And then we have 3 oxygen atoms, so 3 times 16. When you add all of these up, you get 101.11 grams of KNO3 per 1 mole of KNO3. Now this time I put moles on bottom and grams on top so that the moles will cancel, so we can go towards what we're looking for. Now on my calculator, when something's on top, we multiply. So 5.03 times 101.11, we get 508.5833. Again, 3 sig figs here. I'm going to go ahead and round this to 509 grams of potassium nitrate. Let's jump down to problem 3a. This time it says find the number of particles. So particles is either atoms or molecules. Now this time it gives us moles of calcium. Now this is just an element here, so it's made of atoms. So we have 0.0908 moles of Ca. And actually this is made of atoms because we only have 1 calcium here. And we're going to atoms of calcium, so let me go ahead and write that on the right-hand side of the page. Now if we're going from moles to atoms, let's go ahead and look at Mole Island. Moles to atoms, again it's only one step. This time we don't need to look at the periodic table, we just need to use Avogadro's number. 6.02 times 10 to the 23rd of anything in 1 mole. So let's put the 1 mole of calcium on bottom such that it cancels, and the 6.02 times 10 to the 23rd on top. Atoms of calcium. Now again, since this is on the top, this is what I'm going to type in my calculator. 0.0908 times, in parentheses, 6.02 E23, end parenthesis, enter. Now it says 5.466 times 10 to the 22nd, or the calculator says E22. I know that means times 10 to the power. This has 3 sig figs, so I'm going to go with 5.47 times 10 to the 22nd atoms of calcium. Okay, let's go to problem 4 on page 13 now. This is on the moles 2 page. 4. What is the mass of exactly 1 billion atoms of copper? So we have 1, 2, 3, there's 1,000, 1, 2, 3, there's 1,000,000, 1, 2, 3, there's 1,000,000,000. I'm just going to add a decimal point since it said exactly. So we have 1 billion atoms of copper, and it wants to know the mass of this. So this time we're going from atoms to grams. Now let's go back to the mole island. So we're given atoms and we're trying to find mass. Now this is going to be a 2-step problem. We're going to use Avogadro's number on the first step to get to moles, and then we're going to use the periodic table to get to grams. Always focusing on canceling units. Now this time we're going to take our 1 billion and divide it by 6.02 times 10 to the 23rd atoms of copper. And we are going to put 1 mole of Cu on top. And then we are going to put 1 mole of copper on the bottom. And again, look at the periodic table. 63.55 grams of copper are found in 1 mole of copper. So my units have all canceled. So now you're going to go 1 times 10 to the, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9. You could either type in the billion, and we're going to get 1.055 times 10 to the 13th. I'm going to go 1.0. Really, we'd have a lot of sig figs. I'm just going to go to 3 here. 1.06 times 10 to the, negative 13th grams. So this would just be a small mass of copper. Okay, let's look at one more problem. Let's go to G on page 15. So this is on the moles 4 page. This time we're given the number of atoms, and it's asking us again to calculate the mass. So let's put 3.45 times 10 to the 24th atoms of oxygen. Now this is one of the diatomic molecules I asked you to memorize, so it's atoms of O2. And it wants us to find how many grams of O2 this would be. So on Mole Island one more time, we're going from atoms to grams. It's going to be a 2-step problem. The 6.02 times 10 to the 23rd atoms of oxygen goes on the bottom. 1 mole of oxygen goes on top, such that our units cancel. And then 1 mole of oxygen goes on bottom. And then if we look on the periodic table, each oxygen atom is 16 grams per mole, so this would be 32.00 grams of oxygen in 1 mole of oxygen. And then on our calculator, 3.45 times 10 to the 24th, so we would go 3.45 E24 times 32, enter, divided by 6.02 E23, enter. We found out this is about 183 grams of oxygen.